Welcome to our first lesson on functions. So if you have not subscribed to my channel yet, kindly subscribe for more videos. Alright, so let's start. We say a function. What is a function? Now, if you have a mathematical equation, for you to know that that equation is a function, is an equation. Okay, so it's supposed to be an equation. Sometimes too it's not equation, it's just a relation. Alright, I will just explain. Okay, so it's an equation of y. If an equation of y will be a function if for any value of x in the domain of the equation is plugged, if that x here, this x here, let me write it all for you. If this x is plugged in the equation, okay, it's plugged in the equation, it yields exactly one value of y. Okay, so this one value is very, very important. Now, if I have this equation, okay, how do I know that this and this equation, they are both functions or not? Okay, so for me to know that each of these is a function or not, so for us to know that either equation A or B is a function, we'll have to check, okay, if we plug any values in this, they will yield exactly one value of y. Okay, that is basically the idea. Okay, so let's go and check. All right, now, so I have this is the first equation, this is the second equation. Let's try to plug in our value of x there. Now if I plug x in this, I'll get, wherever I see x, I just plug 3 and I'll get 3 squared, okay, plus 1. Okay, and this one will give me what's 9 plus 1, which is 10. Okay, so y is equal to 10. Very simple, like that. Okay, so let's go to the second one. I have y squared is equal to 3 plus 1, meaning y squared is equal to 4, and y is equal to the square root of 4. So y would be equal to plus or minus 2. So what the second solution means is that we actually have one value of x, which is giving us positive 2 and negative 2 at the same time. So this second equation here implies that from the results we've gotten here, this implies that this equation is not a function. Okay, because when we plugged in the values of x in the domain, we had we have multiple values of y. Okay, this is very simple for you to understand. Okay, so in other words, let me take my time to explain something called domain and codomain to you. In other words, I have some stuffs here and I have other stuffs here. Okay, so let's say if I have 1 2 3, let's say 4 5 6 7. Okay, there can be many here. So the first set is called the domain. We'll actually deal with domain and codomain later, but let me take my time and explain it here for you. Domain and codomain. Okay, so what a function is trying to say is that when I pick a value of x here, let's say this is my y, it should map to just a single value of y, not multiple. Okay, so 2 here can also go to 4. It means many of the x's can map to just one. The idea here is that when I pick one value of x, I should get exactly one value of y. So here, what this function here, let's say this is a function f, what this function is trying to say is that whenever I pick y and put 1 in, I'm getting 4. It means 1 will give me only 4. That is correct, I'm okay. When I pick 2 is also giving me 4. It's true, because 2 is just giving only one value, that is 4, not any other value in y. I hope you can get it. So this is what we call a function. Now if 1 was also giving another 10, okay, means 1 can give 4 at the same time can give 6. This means that this is not a function. Okay, all right, so let's go ahead and talk about domain and codomain. So if I have a function, what do we mean by a domain? The domain is what the values of x. That is the definite or the simple definition I can give you. Okay, so the domain is actually the values of x, and then the codomain is all values of y. Now we have a problem here. This boss here is always confusing students. What is the range? The range is values of y computed by the substituting, or by substituting, let me cancel this, by substituting x values in the equation. Okay, so if I have my equation y equals, let's say, s plus 2, now I can say that the domain of y, or the codomain, that is the y values, is starting from 0 to, let's say, 1 to 100. Let's put this way. And I say this is a domain, the codomain, sorry, that y belongs to this. If I say that the domain, let's say x is also given as, let's say, 0, 1. When I put this 0 and 1 in this y, the values I will get for y will be my range. But the codomain is actually the entire set containing all y. But then the range is the values of x, sorry, the values of y we will get when we substitute x in. Okay, so in other words, it's like the defined values of x images. Okay, that is their result in the codomain. Okay, all right, so that is a simple definition I can give you here as well. Let's go to functional notation. Okay, now if I have y equals this, sometimes you want to change the way we write y equals 2s squared minus that and that, and now we can call the same equation here as f of x, meaning this is a function f dependent on x, and is equal to 2s squared minus 5x plus 3. The same thing as j of x, depending on the way you want to call it. Okay, it's actually depending on the way you want to call it. That is very simple for you to understand. Okay, all right, so these are all the same, just showing how differently we can express our function. Okay, all right, so let's go to the next subtopic called functional or function evaluation. Okay, so if I have a function f of x given as this, how do I evaluate some values of x using this function? Okay, so the first one is you are supposed to evaluate f of 2, meaning wherever you see x, you put 2 there. Okay, so f of 2 would then be equal to negative 2 squared plus 6 into 2, then minus 11. Okay, and this will give me negative 4 plus 12 minus 11. Okay, so if you compute this clearly, you see that negative 4 minus 11 will give me negative 15. Okay, then plus 12 will give me negative 3. F of t is just simply putting t wherever you see x. Okay, so get negative t squared plus 6t minus 11, and that is it. Okay, that's what we can do about this, because there is no value for t given here. Okay, it's just that we have f of t, and that is all. All right, let's move on to the last subtopic, roots of a function. When you talk about roots of a function, it's very simple. Given your function f of s equals, let's say, y, let me use a different color for you. Y equals, let's say, y equals s plus 3. Then the root of this function is simply what values of x should I put here. Okay, should I put in this whole equation that y will be 0. Okay, so definitely here we can see that, oh, if I put negative 3 here in place of x, I'll get y equals 0. Okay, so in other words, simply set y equals 0 at that moment, meaning whatever expression given by y, that is the x plus 3, should also be equal to 0. That is what this means. Then you compute for your x, and those values will be your root of the function. Okay, that is what I've written here, that is f of x equals 0. And now we have an example here to do. Okay, we have f of t here given as this. This time our domain is in terms of t, so we are supposed to find the roots of this. Okay, let's quickly go ahead and then find it, and then that will be our lesson for this subtopic or this topic. All right, so if I have this, what I have to do is I have to first write f of t equals 0. Okay, you're supposed to find the roots of this. Now I have now 9t cubed minus 18t squared. Okay, let me write it well for you. 18t squared plus 6t should be equal to 0. Okay, now I can factor 3t out. Okay, 3t out, and I have 3t squared minus 6t plus 2 equals 0. So now if you know how to simplify equations very well, you can see that since they are just multiplying, this 3t here and this is multiplying, you can see 3t equals 0, and that t will be equal to what? 0. Okay, 0, or you could take the other bracket, 3t squared, okay, minus 6t plus 2 equals 0. And now with the help of the quadratic formula, okay, this is a quadratic equation. We say that for the quadratic formula, normally it's stated in x, but in any variable we can do. Okay, so let's compare this to at squared plus bt plus c equals 0. Then we are saying that our t is equal to minus b plus or minus the square root of b squared, okay, minus 4 ac all over 2a. And now with this equation here, we can find our a, our b, and our c as well. Okay, all right, so let's see how we go about it. Okay, now I have t, b, a is what? Let's compare it to that. A is equal to 3. Now b is equal to negative 6. Sorry, yeah, that is it. Okay, and c is equal to 2. So I have my t being equal to, so t is 0 here for the first root, we have that, and t is equal to minus b, so minus 6 minus 6, and that will give me positive 6 plus or minus the square root of b squared is 36. That means negative 6 squared, and that is 36. Okay, minus 4 ac. 4 times a is what? A is 3, 4, 3, 12 times c, which is 24. C is 2, so 4 times 3 times 2, which is 24. Okay, all over 2a, and a is what? 3, so 2 times 3 is what? 6. Okay, so I have 6 over 6 here. Okay, plus or minus the square root of, now 36 minus 24, okay, it's simply 12. Okay, all over 6. If our computation is correct here, then that is correct as well. So this is 1 plus or minus 2 square root of 3 over 6. Okay, I hope you can see this. This is just simple set. Okay, and we have our t here, very simple like that. Our t here equal to 1 plus, now 2 root 3 over 6 will give me root 3 on 3, or t is equal to 1 minus root 3 on 3. So we first had t equals 0. This means that if I plug all these values that I've gotten here in the equation, okay, in our function, we'll get 0 no matter what the values are, since when we equated to 0, these are the results we are getting. Once you plug them in the equation above, we'll get 0. Now we could have taken a very simple example for you to understand, but I just wanted to let you know that it's not always that you get a very simple answer. Okay, so sometimes when you're working towards your answer and you get a huge or some messy answer, just take it like that. Okay, don't always expect an algebraic or very simple algebra value, something like 2, 1, or 3. Okay, all right, so thank you, and don't forget to subscribe to my channel if you have not subscribed yet. Our next discussion talk about the types of functions, and we go to range and domain. Okay, all right, see you next time.